So for multiplying and dividing rational expressions, we're going to start with number 1. If I were to simplify each expression, remember the rules of exponents. And so what would I do with the x squared and the x to the 4th? How would that simplify? X squared would stay on the bottom, so it would be 1 over x squared. 1 over x squared, because I would subtract. The bigger number is on the bottom, so then that would mean that x squared is left on the bottom. If I were to simplify part B, I would isolate the numbers. How would the numbers reduce?
3 over 1.
The 3 would stay on top, so 33 over 11 reduces to 3. And then I would look at the x cubed over the x, and how would that reduce?
3x.
X squared. So my final answer would be 3x squared. For number 2, these are all incorrect. These are just some common mistakes. So if we look at part A, why is part A wrong? Like, why can I not cancel the x squared and the x squared?
They're dividing.
Because I have 2 terms on top. They are dividing. So since I have 2 terms on top, that means the x squareds don't cancel. And they're separated by a plus sign. So if I have 2 terms on the top and they're separated by a plus sign, the x squareds don't cancel. Same thing with part B. I have a plus sign in the middle. So the x's do not cancel. They don't reduce. Same thing with part C. So we're seeing a trend where if the numerator has a plus sign, or even the denominator has a plus sign, like they're separated by plus or minus, things just don't cancel. You cannot cancel terms. You have to cancel factors. So, rules for simplifying rational expressions. The first step is you look for factors that are common to top and bottom, or numerator and denominator. You do this a lot by factoring. We'll see a lot of examples where we factor, or greatest common factor. So you could pull out a GCF, or you could factor. You could do both too. So we're trying to see, can I pull out a greatest common factor, or can I factor the top or the bottom? That's kind of the first goal. So on your pink sheet, step 1 is factor, and that's why it's written so big, because we're going to factor first. Then the second step when simplifying is cancel the common factor and simplify what is left. And something that I want you to write and highlight in bold is you can only cancel factors, not terms. I think there is a meme on my board that says something about a kitten dying if you do this. So if you have x squared plus 1 over x squared and you cancel, a kitten dies. So I'm going to write that on here. Kitten dies, so don't do it. Don't do it. A kitten dies. Yes, I am recording this. Because they're separated by the plus sign. All right, so then the second step. So once you've simplified, we have these things called excluded values. So only times when x values don't work. So all that you do, it's pretty easy, is you find the zeros of the denominator. So you just set the denominator equal to 0. So for instance, a is completely simplified. It works for all real x values except when the denominator equals 0. And that's because it's an undefined function at that point. So you would say an excluded value is x cannot equal 1. What about for part B? If I set that equal to 0, x cannot equal what? I would divide by 4. It would just be 0. Exactly. So for number 3, we're going to follow the steps. We're going to simplify, and then we're going to determine the excluded values. So for number 3, can I pull out any greatest common factors from the top? I can take out an x. I am left with x plus 4. And what can I pull out in the denominator? X squared. X plus 4. Okay, this is the fun part. This is the fun part. I love doing this. You can cancel the x plus 4 and the x plus 4 because they are common factors. We call those factors. They can cancel. I love just putting a big slash mark through it. It's like you can get angry at your math homework and you just slash through it. Then I'm left with x over x squared. And then that can simplify to be what? 1 over x squared. No, 1 over x. 1 over x. I tricked you. So 1 over x, but x cannot equal what? 0. Good. All right, let's try number 4. All right, so if we look at number 4, if I were to factor the top, I get x plus 3, x plus 2. So sometimes you can't pull out a greatest common factor first. Sometimes you can. Then on the denominator, I could factor that to be x minus 5 and x plus 2. And now I get to slash through them. So x plus 2, that goes away. I am left with x plus 3, x minus 5. That is my simplified answer. I can't do anything else because remember the x's cannot cancel. And my exclusion would be x does not equal negative 5. Or it should be x minus 5, so x does not equal 5. I just wrote it wrong down here. The excluded x value means like on a graph, that's where it would be undefined. So if your denominator is ever 0, that becomes an undefined function. So it'll work for every x value except when your denominator is 0.
Wait, so since there's 2 solutions,
so for number 5, I get x plus 6, x minus 1. On the denominator, I can factor the x squared minus 1 to be x plus 1, x minus 1, x plus 6. The things that cancel are x minus 1, x plus 6. So I am left with 1 over x plus 1, and x does not equal what? Negative 1. Good. All right, so now we're going to multiply and divide. That's like combining rationals, but then you're going to do the same steps. So simplifying, multiplying, dividing are all kind of the same. It's just combining them together. So the first step is, if it is division, how do I divide a fraction by a fraction? You flip the second and then multiply. So flip the second rational and then multiply. So second step is you factor both numerator and denominator. Like we did with simplifying, you factor both of them. You combine and write as one fraction. Then you simplify, so the steps that we just did. And I'm going to say leave in factored form. So I don't need to multiply them back out. And then the page kind of got cut off, so go ahead and flip to the next page. I know. Okay, so let's look at number 1. I'm just going to look at the first numerator denominator. If I were to factor the top, it would look like x plus 3 and x minus 3. On the bottom, if I were to factor that, what could I do? Okay. 8 and 3, so x minus 8 and x plus 3. Then I'm going to look at this second one. I can't do anything to the top, x minus 8. What can I do to the bottom? Can I pull out a greatest common factor? 2x. Then I'm left with x minus 9. So this is the fun part. Combining means just writing it across. Sometimes I don't even write it as one fraction because that's an extra step. I just start canceling things. So I can cancel x plus 3, x plus 3. Even if you have a factor on the top left and the bottom right, they still cancel because I'm writing it as one fraction. Like the combining just means that it is all together, like it is one fraction. So the x minus 8s will cancel. And then there's nothing else left that I can cancel, so I would write this as x minus 3 over 2x, x minus 9. You can leave it in factored form. So what that means by leaving it in factored form is I don't multiply the 2x out. I just keep it like it is. And so then if I were to find my restrictions or find my excluded values, that means I set this equal to 0 and I set the parentheses equal to 0. So I'm going to have two x values that I cannot have. The first one is if I set 2x equal to 0, x cannot equal what? 0. If I set the bottom or the x minus 9 equal to 0, x cannot equal 9. Perfect. So this would be my final answer right here. Let's go ahead and look at the divide because I want to save some time. So if I do the divide, the only extra step that I add in is I switch the x plus 1 and the x plus 5. So I have x squared minus 2x minus 3 over x squared minus 4 times x plus 5 over x plus 1. So all I did is I switched, kind of like whenever you're dividing a fraction by fraction, flip and multiply. So then I take the top and I'm going to factor the top. So I'm going to just come up here for some extra space. If I were to factor the numerator, it becomes what? X minus 3, x plus 1. And then I also now have the x plus 5 at the top. Divided by x squared minus 4 is a difference of two squares. So x minus 2, x plus 2. And then on the bottom I have x plus 1. So things that I can cancel, I don't have very many. It's kind of sad. There's a few examples where everything cancels. So if you go and look at my Blackboard notes, I have like, this is so much fun, everything canceled on there. Oh, that doesn't cancel. Don't know what I'm doing. X minus, it would just be 1. So things that cancel, x plus 1, x plus 1, I think that is it. So I have, on the top, I'm going to leave it in factored form, x minus 3, x plus 5, over x minus 2, x plus 2. And then my excluded values would be setting x minus 2 and x plus 2 equal to 0. So x cannot equal 2, x cannot equal negative 2.